Today we'll be discussing the essential criteria used to evaluate and select electric motors for electric vehicles. These criteria are not randomly chosen. They are drawn from range of peer-reviewed literature resources and represent the most critical performance and design characteristics a motor should have for EV applications. So why these criteria are actually matter? So why actually we need this criteria? The first point is just discuss the importance of these criteria. So, what is the main important why we need to discuss this criteria? So, first thing is the EV motors must deliver performance, safety, and cost effectiveness. This is one of the major reasons why uh, every EV motors we expect to have them a better performance, safer in operation, and also cost effective. So these selected features, what we will be discussing, these selected features will ensure that motor operates reliably under various conditions. Ensures motor operate reliably under various conditions, also while meeting the consumer expectations and the regulatory requirements. So now let's break down each of these criteria one by one. So first we'll be starting with number one criteria, that is torque ripple. This is the first criteria and the most important criteria that we have. Now, what is this criteria? The torque ripple we mean. Uh, it is the variation in torque output during rotation. So, coming to the definition, it is variation in torque output. So, during rotation, what variations we have in the torque? It's called as torque ripple. Now, why it actually matters? Now, if you have excessive torque ripple, it leads to mechanical vibrations. The first thing, it leads to mechanical vibrations. Then we have reduced ride comfort. Because of the increased mechanical vibration, we have reduced ride comforts, and also you have increased noise. The increase in the torque ripple actually increases the noise. So if you this is when you have high torque ripple. This is the consequence of high torque ripple. Now this needs to be minimized. You need to have minimized torque ripple in order to get better performance and better durability. This is the reason why torque ripple is important in terms of performance and durability. The next criteria is the noise level. It is evaluate the next criteria. It is the noise level. So coming to noise level, it is the audible sound produced during motoring operation. Now, whatever audible sound we have during the motoring operation, that is given by the noise level. So if you have low noise, it contributes to a quiet, comfortable ride. So it's completely based on quiet and comfortable. Right. So one of the major selling points of EVs, because most of the consumers expect the cars to have a very quiet sound, or as minimum sound as possible, because that again is a criteria for evaluating the comfortness of the vehicle. The next criteria, major important technical criteria we speak is the efficiency. We don't have to, I don't have to define what the efficiency is. We all know what do we mean by efficiency. How much useful power we get as an input for a given, sorry, useful power we get as an output for a given input. So when you have high efficiency, it straight away signifies better battery usage. Better battery usage. You can have extended driving range, which means you can go for a larger distance for a given battery charge. So, extended driving range and reduced energy cost. So, these are the reason why you need to have a better efficiency of EV motors. The next criteria, that is the fourth criteria we'll be considering, is the cost, and we don't have to explain regarding the cost. It is the total cost of the motor, including its manufacturing, materials, and integration. So, being cost effective is not only important for the consumers, it is also important for the manufacturer to have a mass market adoption. So, if you want to get into a mass market, if you want the EV to be adopted within the mass market, we have to make sure that it is affordable, and making using components which are cost effective within the EV framework becomes very important. The next criteria is the size. Always EVs we speak about compact size. We don't have a lot of space resources when it comes to EV. So the physical dimension and the packaging of the motor should be as small as possible. So if you have a compact size, when we speak of compact size, it actually ensures optimized vehicles space, optimized vehicle space, and it also ensures design flexibility. So you can have flexibility when it comes to designing the, the vehicle. The next criteria, that is criteria number six, is the reliability. Uh, we all know the definition of reliability, how dependent you can be, how dependent you can be on particular motor. So it is the ability to perform consistently over a time without any failure. That is what reliability actually means. So it ensures safety. So when we speak of reliability, it ensures safety. That is the first thing. Then it reduces maintenance, because the fault occurrence is actually less, so it reduces the maintenance. And last thing, and also the replacement need, so you don't have to replace any parts there when the reliability of the motor is very high. And the last criteria, not with the least criteria, sorry, it's not the last criteria, we have a couple more criteria. Okay, it is the fault tolerance. Fault tolerance. So it is the ability to continue functioning under fault conditions. Even if you have certain faulty conditions in the motor, it should perform the function as it is being designed. So it is critical for maintaining vehicle operation and safety in the event of component failures. So again, fault tolerance is another way we can increase the reliability of the vehicle. And the eighth one is overload capacity. So coming to the overload capacity, uh, it is the ability to operate above the rated load for a shorter duration. You might have a load of 50 kilowatt, that is the design load. And if you want to operate the motor slightly above 50 kilowatt, for example, for 70 kilowatt, for a duration of some 10 seconds or 20 seconds, it should be capable of having that capacity. It should have that capability to operate even at the higher load for a shorter duration of time. So this is why it actually matters is the overload capacity actually matters when we have scenarios such as acceleration, then hill climbing, and temporary performance boost. If you need to have a temporary performance boosts in these scenarios, the overload capacities becomes important. The next criteria we speak is of power density. We have already spoken about power density a lot of times when it comes to energy storage system. Okay, so even for vehicle, we speak about power density. So what do we mean by power density? It is the power output per unit volume or weight. So if you have output power divided by the volume, either the volume or weight of the motor. Now, this means that if you have high power density, it actually means you have a lighter and compact motors. And I need not again explain why do we need light or compact systems without sacrificing the performance. We can have lighter versions of the motor. Also, the compact design can be done. The next one is wide speed range. This is the most important criteria, though we are discussing at the later part, but this is one of the most important part here. Now, what do you mean by wide speed range? So you might have a range of speed, and at all the speed range, it needs to operate efficiently. So the capability of the motor to operate efficiently over a broad range of speed is what we call as wide speed range. So it is important that we should have high torque even during low speed operation. The motor should perform very good at low speed operation, as well as it should have a very good performance during high speed cruising, because you cannot have always some fixed range of speed. You might go for 0 to 50 kilometers per hour, you might go for 100 kilometers per hour, or you might go for 120, 180 kilometers per hour. So whatever performance is required from the motor during those ranges, we must have, because initially we must have a high starting torque. When we go for high speed cruising, again there this torque requirement is there. Along with that, the power output is needed. So all this is required. So wide speed range is another important criteria. So the last criteria is control simplicity. The controller what we use, how do we control the speed torque of the motor? That controller, it should be as simple as possible, so that it is easy to implement the control systems there. So simplified control reduces the developmental cost, it improves the robustness of the entire drive system. So we have seen 11 different criteria which provide a structured way to compare and evaluate different types of motors such as PMSM, then we have induction motors and switch reluctance motor. So these are the criteria which we are using to evaluate different motors. In the next video, we'll try to compare different motor drives with respect to these 11 criteria. Thank you.